Hi dear friends, good day and welcome to my YouTube channel. And this is still from the Cambridge 2013. It is still from the Cambridge 2013 question 4. It's still on integrations, and they want us to show that. And please, I'm sorry I didn't tell you guys my name. My name is Macarius. I'm called Omenjo Macarius. Those are my names. And please, the question wants us to evaluate the definite integral from 0 to pi over 4 of sec nx tan x dx, which will show that this definite integral is the same as the square root of 2 all that to the power n minus 1 all over n. Now let's proceed. Like I said from the previous video, that in integrals, tangent and secant are best friends because we have secant x, we have tangent x, they are best friends. Now, but in this case, we only know for sure that the derivative of tan x gives us sec squared x, right? And some other stuffs. But in this case, we do not know it. But in this case, we don't have sec squared x, so there's some more work we have to do. So it will be so interesting for us to see this sec nx as we have the integral going from 0 to pi over 4 of, now if we look at this we can look at this guy as sec n minus 1 of x. Now then we write sec x tan x dx. Now the reason for doing this is that this sec is raised to the power 1, then this other guy is raised to the power n minus 1. And from our law of indices, where you're multiplying two quantities that their bases are the same but their powers are different, or their powers are the same, or anyhow, if as long as their bases are the same, you can simply add the exponents. In this case, we have n minus 1, then we have 1 here. So what's n minus 1 plus 1? It just gives us n, and that's exactly what we have. Then this tangent x dx. So now let's proceed. In this case, like we did in the previous session, we can do a u substitution. We can let our u to be secant x, such that our du is equal to what? If you differentiate sec, you still have back the sec, then tan x, we end with our dx. So the derivative of that's du is equal to what? Sec x tan x. And if we look for here now, we'll see that this is our sec x tan x, which is our du. So we can now take this integral now from the x world to the u world. That therefore means we are now going to have integral. Let's change the limits of integration. These are the x values, x equal to pi over 4, x equal to 0. So when x is 0, you put in 0 here. What's sec 0? Sec is the same like 1 over cos. What is cos 0? Is 1. 1 over 1 gives us what? 1. So this man is going to 1. Then if you put x equal to pi over 4, if you plug it into here, like I said, sec x is the same like 1 over cos x. What is cos pi over 4? Cos pi over 4 is 2 on 2. But 1 over 8 gives us what? 2 over 2. Yes, 1 over 8 gives us 2 over 2. So these are the limits of integration now. Then this sec, that is now going to be u raised to the power n minus 1. Then this sec x dx is our du. That implies we are now going to have the definite integral. At this point in time, let's just integrate such that we don't waste unnecessary time. Let's integrate. Let's do the reverse power rule. We add 1 to the power and we divide that by the new power, which is n minus 1 plus 1. So what's n minus 1 plus 1? Is just n, right? So in this case, we're now going to have just 1 over n. Yes, just 1 over n here. Then here we're going to have u raised to the power n. That's good. And the limits are from 1 to 2 over root 2. Yeah, good. Or we can look this 2 over root 2 as, because if we multiply by root 2 and here by root 2, we'll see that these two guys are going to give us 2 cancels. We just have our root 2 back. So let's plug in the limit. Well, we're now going to have 1 over n is outside, then we have root 2, because we are putting it in place of u, root 2 to the power n minus 1 over n into 1 to the power n. Since 1 over n is common, since we have 1 over n, we can factor it out to get 1 over n into, we have root 2 to the power n, then minus, now 1 times 1 times 1 to the power n, because 1 to the power anything is just 1, so we just have root 2 that minus 1. So our answer now turns out to be root 2 to the power n minus 1 all that to the power n. And since this is a proof, we must say as required. Yeah, thank you guys for watching, and please subscribe to my YouTube channel. Please, I'm begging, please subscribe to the channel. I just started, okay? So please support me by subscribing, and please like the video. Please like the video, okay? Please like the video so that you can motivate me to produce more and more videos. And please, if there's a question in pure maths, chemistry, physics, feel free to let me know, okay? Feel free to send the question over to me. You can send through my email. That's macariusomenjo@gmail. That's macariusomenjo95@gmail.com. Please, this is my email. You have Macarius, all in small letters, Omenjo 95, then at gmail.com. Please, as long as you email me with this, I am going to respond to you, okay? I will respond to you. So please like the video. Just give it a thumbs up, okay? Please like the video, and please share it out with your friends. Share it out so that, like I said, I'm going to produce more and more videos for you guys. If you have any question that is bothering you, email me, send to me, or my WhatsApp number. You can send me. You can either send through email or you send through WhatsApp. My WhatsApp number is 651-047003. You can send it through this WhatsApp number, and I'm going to reply to you as soon as possible. Thank you.